Welcome to qnawire.
A cannon located 60 meters from the base of a vertical 25-meter tall cliff shoots a 15-kilogram shell at 43 degrees above the horizontal towards the cliff. What must the minimum muzzle velocity be for the shell to clear the top of the cliff? And part B, the ground at the top of the cliff is level with a constant elevation of 25 meters. Under the conditions of part A, how far does the shell land past the edge of the cliff? Okay, so it's a projectile. So positive x is going to be pointed up. Sorry, positive y. Positive x is going to be towards the hill. So to clear the top of the hill, x minus x naught is equal to 60 meters. The shell has to reach 25 meters high. We know the acceleration in the x direction is equal to 0. Since it's falling down, the acceleration in the y direction is negative g. So we also need the velocity in the x direction and the velocity in the y direction. So this is v naught cosine of 43 degrees. And this is v naught sine of 43 degrees. For part A, we know that x minus x naught is equal to v sub naught x t. So we know x minus x naught. So this gives us t is equal to 60 meters over v sub naught cosine of 43 degrees. Looking at the vertical motion, y minus y naught is v sub naught yt plus 1/2 at squared. So this is negative g t squared. So plugging in this time into this equation and knowing that y minus y naught is 25 meters, we can solve for the only unknown, which is the velocity, so v sub naught. So we can say that this is v sub naught sine of 43 degrees t plus 1/2 negative g t squared. Solving for v sub naught using algebra, we get 32.6 meters per second. And now knowing this velocity, we find that the time is 2.51 seconds. So for part B, we have that the velocity in the y direction is the initial velocity plus that other velocity. So plugging in values, we get negative 2.4 meters per second. So it is traveling downwards.